Hello and welcome, this is Matthew with this very nice looking integral today. And the way I'd like to solve it is by using Feynman's trick and a little bit of complex analysis. So let's not waste any time, let's get into this integral. First, I'd like to use the double angle identity for sine of 2 theta right here. Then I would like to use the properties of the logarithm right here. Next, I'd like to define a function I of alpha as this integral right here, so that if we differentiate it with respect to the parameter alpha, and then plug in alpha equals 0 right here, we get back our I integral. Next, recall that the imaginary part of e to the ix equals sine of x, because e to the ix equals cosine x plus I sine of x. After using Euler's formula right here, we find ourselves at this representation for I of alpha right here. Next, make the substitution, let z equal x to the k times 1 minus 2i, and we see our limits right here are not bothered. Going through with the substitution, we find ourselves at I of alpha equals this guy right here. Next, we recall the gamma function right here. And if we use the gamma function right here, this implies that our I of alpha transforms into this guy right here. Next, we need to find the value of this guy right here. Well, how would we do that? Well, first we need to recall that the imaginary part of x plus y times I to the power of n right here equals this guy right here. So this would imply that the imaginary part of this guy right here is equal to this thing. Using the result we just found for this guy right here, this implies that I of alpha equals this guy right here. But recall that I equals beta over 2 times I prime of 0. Well, we have I of alpha, now we need to find I prime of alpha right here. Okay, now it's time to take the derivative of this guy right here. And basically the way we're going to solve this derivative is by just using a long version of the product rule. Now here is the long version of the product rule I was talking about. Now it's time to evaluate each individual derivative. First, we have to evaluate this derivative right here. Now, this derivative right here is pretty easy to evaluate. You just have to use a little bit of the chain rule. Sorry, I couldn't remember the name. Next is this derivative right here. It's pretty simple. All you have to do is use this little derivative right here. And there we go. This is the answer right here. And this negative 1 over 2k comes from a chain rule that you have to do to evaluate this derivative. Next is this derivative right here, which is pretty straightforward. All it requires is the chain rule. And here we go. Here's the answer right here to that derivative. Now if we apply all those derivatives, we find that I prime of alpha equals this guy right here. Then if we recall that I equals beta over 2 times I prime of 0, that means that I equals this guy right here. Because if we just, we have I prime of alpha, if we plug in 0 for alpha, we get this guy right here. And then all we need to do is just multiply that thing by beta over 2. So here we go. This is our answer right here. Here we are. Here is the final result for this integral right here. Sorry if I went a little bit fast, but feel free to pause the video to see what I was doing. Okay. I would really appreciate it if you could like and subscribe if you like this video. If you did not, it's okay, but have a good day.